Hi, science students. Welcome back. We're going to deconstruct AKS 7E together. Let's first read the standard, analyze and interpret the concept of specific heat data to justify the selection of a material for practical application. And they give you some examples, insulators and cooking vessels. So let's first go through and highlight all of the key terms in the standard. I think analyze and interpret are going to be very important. I also think specific heat data is going to be very important. Selection of a material is important to know that that's what our goal is to be able to do, to select a material. And lastly, we're going to identify practical application as another key term. So let's start with those science and engineering terms, analyze and interpret. So when we analyze and interpret something or data specifically, in this case, when we're doing that, when we're analyzing and interpreting that data, what we're doing is we're examining data and we're making sure as scientists that we are able to explain what that data is telling us. So be able to explain the meaning of the data. So as a scientist, in order to be able to analyze and interpret any sort of data, I need to be able to examine that data and be able to explain the meaning of that data. So let's go on. Our next term that we highlighted is going to be this specific heat data. So I'm going to draw a little green arrow up here. Put all my information about specific heat data up here. So we know that specific heat capacity is going to be the amount of heat energy required to raise the temperature of whatever material we're looking at by 1 degree Celsius. Let's make that look like a little more of a C for Celsius. So specific heat capacity is going to be the amount of heat energy required to raise the temperature by 1 degree Celsius. We also know that there's a formula involved when we're talking about specific heat data. And so I'm going to write that formula in the middle right here. E equals specific heat times mass times difference in temperature. That can be written like this, or that can also be written like delta, a triangle, T. And that's really your prerogative, which one you choose. So let's label what these mean and what their units of measurement are. We know that the E is going to stand for energy transferred. And that's going to be measured in joules. We know that the C is going to stand for the specific heat of that particular material. And that's going to be measured in joules per kilogram degrees Celsius. That's kind of a long unit of measurement. We know that the M is going to stand for mass. And that's going to be measured in kilograms. And that the difference in temperature is going to be measured in degrees Celsius. So let's keep going. Let's talk about the selection of a material. So the selection of the material, in order to select whichever material we're going to use for this practical application, we need to identify an answer to the question as to why we want to use that material. What about that material makes it the best material for use? So right here, I'm going to draw an arrow down and I'm going to say, answer the question, because that's what we need to be able to do. We need to answer the question, why did we choose this material? What about it made it the best for insulation or the best for conduction, depending on the case we're talking about? So we want to be able to make a selection and identify and defend why we've chosen that material. Lastly, we highlighted practical application, and really all that means is everyday use. So when I use something practically, it just means I'm using it in my everyday life. So right here, I'm just going to write everyday use. So the only things left that I want to talk about are going to be insulators and cooking vessels, these examples that they've given. So let's start with insulators. I'm going to highlight it with my blue pen here. Insulators, we know, are going to be the best material to keep something from getting hot quickly or keep it from getting cold quickly, depending on the scenario we're in. So I know that an insulator is going to have a high specific heat. And I know that the reason that it has that high specific heat number is because it requires a lot of energy. To heat it up. So if I'm looking to keep something from getting hot really quickly, I certainly want to use an insulator because I know that it's going to require a lot of energy to be put in, or it's going to have to absorb a lot of that energy before it will actually increase in temperature. And that's why we choose insulators for certain things like cooking utensils that we're stirring in the pot. We don't want those to get hot and burn our hands. So we may choose a material that has a high specific heat, like wood, as our cooking material so that we don't burn our hands. It doesn't heat up as quickly. So then let's lastly talk about these cooking vessels. All that means is pieces of equipment that we use to cook food. So I'm going to draw a little red arrow down from cooking vessels, and I'm going to first write that these are called conductors. And in this case, these are thermal conductors. We know that conductors are going to have low specific heat. And that number is going to be low because they require very little energy to change temperature and heat up. So by the end of this standard, we should be able to look at data and be able to explain what that data is telling us. We should be able to identify the specific heat of any material and be able to identify how we would use it in everyday life based on its specific heat capacity. If it has a high specific heat or a low specific heat, we're going to be able to determine that this material is best to be used in this way. That's everything that I have for you today. Pause the video if you need to copy any of this down. Have a really good day. Bye-bye.